right. Good afternoon, everyone. My name is Harsh. I am a solutions architect at DBT. Been here for about 2 years and have been in the data space for the longest time. Started writing MapReduce jobs to Spark jobs, and now I'm at DBT. So today I'm going to talk about how DBT can enable a lot of your AI use cases and how DBT fits in this landscape itself. But before I start, I had to use AI to create an image to show you what is happening with AI itself. So what are we talking about today? So when you are adopting DBT, there are a lot of things that you would be trying to accelerate when you're talking about your model training or your pipelines itself, when you're looking at AI models. So what are the things that people are normally focused on? It's about building the analytical code in your pipelines. What is the code? How are you building it? Can it be automated? What parts of it can be automated? Now that you build these pipelines, what are you testing? How can you enable those tests faster and have ways that you can debug a pipeline? Once a data pipeline has been built, there are a lot of times where it becomes tough to debug pieces. Now, if you can have pointed places where you can see, okay, this data pipeline has an issue, it's right here, and get recommendations on what pieces of that pipeline need to be fixed. That is the best part itself, right? And then having a way that you can monitor on not only the pipeline itself, but the resources that the pipeline is consuming or how the pipeline is performing over a period of time. So having any anomalies, whether it's based on seasonal patterns or it is based on any other problems, how do you get that information itself? So those are the things that become really important. And when you're looking at your data, you need a way that you have a control plane on this data itself. And how does that look? So before we talk about that, there are a few challenges. We spoke about what we can enable with DBT itself in your data pipelines. But when you start trying to work with AI, there are a lot of problems that come in. One is, how do you build trust with the data itself? How can you make sure that the data you're taking actionable insights on, how up to date is it? And even when you build the data stack itself, how optimized are these queries from a cost perspective and from a performance perspective to get that information? So that's really important. So what if you can do all of this or get all this insight based on the data that you already have? And how does that come into play is if you have an architecture where you look at a control plane in this particular way. At the bottom is the data platform over here. The data platform is where you house all your data. So it sits all the data right from the raw to your aggregates and your dashboards to your machine learning models are all baked in over here. So once you have a data platform, the first step again is to ingest these pipelines and make sure that, okay, you're ingesting the right raw sources. Once the sources have been ingested in a data platform, then one important thing is to orchestrate these sources. So how are you orchestrating these sources? A time-based orchestration, or you have triggers based on data being landed and then building on top of those data sets itself. And once you've got these pipelines in play, you want to know how well can you observe these pipelines. One is from a perspective of understanding how these pipelines are performing itself. Second is just to get instant feedback as to, okay, this doesn't feel right, and be able to perform these tests in line with every specific pipeline. A catalog becomes a really important thing. As you build these pipelines across the organization, these pipelines grow. The number of data models you're working with grow exponentially. Then you want a place where you can go and discover these pipelines. You want to see what has already been built, be able to understand how it is fitting into a particular pipeline, and be able to reuse some pieces of it in your pipeline itself and build on top of it. So a catalog is really good right from a data discovery standpoint when you're building off something that's already been baked in the platform, or you're trying to enhance a pipeline or reuse elements of a pipeline that's already there. You also want your catalog to be stateful in a way that is giving you information about, okay, this pipeline ran. I want to understand what were the tests that were performed on this pipeline. I want to understand more about every element of this pipeline itself. So that becomes really, really important. And one important thing over here is semantics. So now when you have built your data pipelines, you have people who are using these tables, you want to make sure that everyone is building a KPI that's built once. The metric is built once and is used by all your interfaces. So this interface can be a BI tool, it could be a JDBC interface, it could be a notebook. But you want all of that to adhere to the same semantic, because what we've seen over a period of time, people tend to build metrics or build semantics and put it in a BI tool, or they will put it into the data platform itself. If you're able to define a metric in one place and make sure all the tools that are using these are able to address the same metric, it gives you a lot of power, because then you don't have the sprawl of metrics across the organization itself. So these are the things that are important. And one of the biggest piece over there is how do you perform these transformations itself. So one thing that you see over here is the control plane. This is at a high level, but if you were to drill down deeper and see what are the different pieces that are a part of this ecosystem, then the landscape starts to look like this. You see dbtlabs is focused on giving you the transformation, and like I said, we are the control plane of your data assets itself. So over here, Databricks is the data platform. You have a lot of tools in the ingestion workspace and a lot of BI tools over here. We are trying to make sure that we can make the transformation of your data in a way that you can have all of these other metrics that are defined out of it, right from the orchestration to the observability to having a catalog that houses all the data pipelines, and to be able to build the semantics on top of those pipelines itself. That becomes really powerful when you're building these assets. What I want to do right now is show you a little bit of how DBT helps building these assets itself. So I'm going to do a quick demo. I'm going to show you, we spoke about the catalog, we spoke about the semantics, we spoke about observability. I'm going to talk through the entire workflow, show you how you can first explore the pipelines that are already built in your platform, and then how do you go about constructing these pipelines. And what you see over here is, let me go into. So right now I am in a DBT project. This is the landing page. This is the explore interface. This is where you can explore the data pipelines that have been built, all the data products that are a part of your environment. So when I click on explore lineage, what it does is it gives me an understanding of what are the pipelines that have already been built, right from the stages to what are the raw files. So these are all the sources that are a part. On the left are all the sources. And as you start moving right, you start seeing all the steps that were done to build these sources into aggregates and eventually into exposures, which is synonymous to dashboards, and the metrics that you're working with. So all of this information is available to you here. So if I go deeper into a particular data model, so let's say I am looking at fact orders data model. So this is a data model that is a step in my pipeline. And this data model over here is showing me the isolated lineage. So I had these data models that were used to build this data model. So I have order items, and I have part suppliers that were used to build the fact order items. I get a lot of information on what are the tests that were performed on this data model. This becomes super powerful when you're trying to build a pipeline. So what you're saying is, I have this particular data model that I've built, and I have performed these tests on the various columns in this data model. So I have that level of information, and then I can go in and look at the code. So when I look at the code, it tells me what was the code that was used, all the configurations that are boilerplate, the CTEs, whether it's a view, a table, or it is an incremental load. All of that information is available here. And then you have your code that's written. So all the code is available to you here to see. And then when you go into the columns, this is where you get a lot of information on what are the columns of that data model. So when you look at the columns, you have information, the columns, the tests that were performed in those columns. And you can go one step further and look at columns and look at the evolution of the column itself. So when you look at a column over here, let me look at a column. So when you look at a column over here, it tells you right from what were the operations that were performed. So you see the lens. It tells you, okay, this was the first step was transformation. Then we did a rename. Then we went and did a pass through on this particular operation itself. So you could choose the lenses. The lenses could be resources, whether these are models, or you can look at the evolution itself in this lens, where it tells you like this particular column from your source to your target, this is how it transforms. So it could just be a rename operation, or you went a step further and you did a transformation on that particular piece. This gives you a lot of power because now you're not only looking at your data from your source to your target and looking at just the tables that were used to transform them, but you're getting another level of granularity where you're able to see what models in this place were used, what columns were used, and how did they either branch out to build multiple columns or be accumulated and made one column itself. So that was about just going and exploring what data assets exist. So now when I showed you the lenses over here, you have multiple lenses also over here. So when I use the word lens, you can think of it as a layer on top of a map. So the first level shows you just the basic materialization. So it tells you whether it's a model, whether it's a data model, whether it's a source, whether it's a snapshot, whether it's a specific metric, or it is a semantic model itself. You can also look at ways where we were talking about observability metrics over here. You can look at the latest status. So when I look at the latest status, it tells me about the status and tells me, okay, these models ran successfully. And if there's any issue that happened, I can go drill down deeper in this model and see what caused this data model to fail. So you have that level of information just to be able to layer on top of your overall lineage. And over here, I have the tests. So over here, I can go to the tests and gives me the state of the test. So you can see a few tests that are won, few have passed. If I want to go and look at a won test, I can go and look at this particular instance. It'll show me the instance of this particular run, and I can see the warning over here. And when I look at the warning, it takes me here and it tells me, okay, so this was a test, it was a warn, this is what happened. And I can go ahead and look at what was the information, what was the code that ran for this test, and then go and change it, and then eventually rerun the pipeline from the point of failure itself. There are a lot of performance stats and recommendations that we capture too. So what we're able to understand is how your project is structured, and then give you information on what is the state of the project itself. So over here, your DBT project has, it's got 68% coverage for your tests, and the model documentation is about 77%. You can choose the guidelines that you want or what are the benchmarks. These are soft recommendations, gives you a high level. You can also bake this in your CI pipelines where if you reach a stage where you drop below a threshold for your project summary or for your model tests or documentation, it could stop the code from being committed to your version control itself. So you have that level of flexibility when you're building this code. And it tells you over here as to what are the pipelines and what pieces of the pipeline are need to be changed, or what recommendations we have, whether it's testing or documentation that needs to be added. Now, I'm going to talk through just the developer experience. So throughout this process, what we were looking at was the pipelines that are already built. We have a lot of information on, okay, so these are the pipelines that are built. This is what has happened within the pipelines. Now, if I want to go and change any part of the pipeline, how do I go about doing it? And what are the pieces that I can use so that I can contribute to the code and also debug a lot of these pieces that could have changed in a period of time. So what you see over here is the IDE. This is connected to your version control platform. So it could be Git, Bitbucket, GitLab, or if using Azure, it could be Azure DevOps based on the code commit, the version control that you're using. So what you see over here is the code itself. We are working with fact order items. I can click on fact order items over here. So what it does is it pulls up the code, and this code is live. So I can go here, I can go and preview the code. This runs against the Databricks cluster and gets me this piece of the code back. Really powerful as you're iterating and making changes to the code. You get the information here. You can compile the code and see how the code is being compiled, and then eventually build these models and persist them as tables within tables of views within your Unity catalog or the Hive Metastore where you're using. So one of the most powerful pieces over here is each developer has their own environment. So they're not stepping over anyone else's feet when they're building their data pipelines. So as you prototype, you're working off a feature branch, and as you commit your code, your code gets committed to the main branch, and that runs in the higher environments, whether it's your staging environments or your production environments itself. And we have linting operations. So you can use SQL fluff over here, define your SQL fluff rules, and make sure that as you propagate the code, it is adhering to the right linting strategy that the team has. We've also added this concept of dbt assist. What dbt assist does is it helps you generate a lot of the documentation and the tests that you would normally be doing yourself. So we want to give you that additional level of help where you can generate these docs. So when I do a generate docs, it performs an operation, it generates the docs. It has all the information about the metadata and the models that we're working with. So it starts generating the docs for you. And based on certain parameters that it knows, primary keys or foreign keys, it will start adding those tests to it. You can also go ahead and enable or change these pieces. Super powerful when you're trying to automate some elements of your pipeline. So now you saw the documentation coverage was 75%. If people have this feature already, they can increase the documentation coverage, and kind of helps everyone in the team itself, because then they're able to see what exists. And as you see this YAML file of the tests and documentation be generated, the DAG also gets generated right below. Super powerful feature. And then when I go ahead over here, I can go and run the pipelines itself and develop them here, do the build operations. And this is the development workflow. So that is great, right? So now I've developed my pipeline. Now, how do I go about putting these pipelines into production or any higher environments? So in dbt, we have this concept of deployment. You can create a job. So a job works off your branches. So it could be a feature branch or it could be a main branch, and it is associated with an environment. So when I click on the environment over here, so it says these are the environments I have. I have a development environment, and I could have multiple environments. So I'm more interested in my production environment, because I would be deploying these pipelines to the production environment. So now the first step is to create a job. And when I create a job, I can choose what kind of a job it is. It could be a deployment job. A deployment job is simple. It could be a trigger-based, or it could be a schedule-based job. And when I create the job itself, I can choose the job. So I can give it a name over here. Let's say it is a daily run. I can choose the execution, the commands that I want to run. I can choose it to run on a particular schedule. And I can then choose it to be chained to other jobs within other projects itself. So now you have the capability of having these jobs that on completion trigger other jobs. It could be other projects, or it could be within the same project itself. So you could choose, and then you could choose the job that you want to trigger after this particular job. Once you've created the job, you have all the run history available here. And the run history gives you information on the job run itself. So we are talking about a lot of the observability metrics. They're available here. So you have information on the invocation, what happened when the job ran, what is successful, what is the warning over here. And then you are able to go and look at the lineage itself as to this particular job worked on a subset of my lineage. So I have multiple data models within my project. I was able to run a piece of them here. And again, model timings. This is very powerful because you have information on, okay, this model ran, how long did it run? And okay, this model took a little longer, for example. So I can go in and go back to Explorer, and takes me back to this data model, and it tells me, okay, this is what this data model is doing. The last was a successful run, and it ran on the 11th of June. I can go and look at the code and make changes if I have to. And then I can also look at all the other stats of this data model. And then if I'm sure that, okay, this model could have some issues because I'm seeing something in the code, I can go ahead and open it back into the IDE. And when I open it back into the IDE, it takes me to this particular data model. I can make the changes right away and then commit it to the underlying source. The one thing that I didn't talk about, right? I was talking about everything in the context of a project, but you also have the ability to see how different projects are connected. So over here, you could have a foundational data project, that is the data analytics project, that is connected to other projects also. So you would have data models that are published as public data products, and they are accessible to the other data models itself. I believe I've run out of time. And that's what I wanted to show. And I appreciate everyone over here. Thank you so much. Thank you.